trinomial. So the first thing, anytime we're asked to factor something, what's the first thing we should look for? Descending order first. So descending order first. Descending order. And then the first real factoring that we're doing is that GCF. We look for a greatest common factor across the entire problem and try to factor that out if there is one. A lot of times there isn't one, okay? But we're looking for that to start off. One reason that we're looking for that is because we really should find the greatest common factor first. Another reason is it makes our numbers smaller, and that's going to be really effective today as we're doing trinomials. The third thing that we would do is we would count the terms. And last week we did ones that had 4 terms, and when they had 4 terms, we used grouping. Okay, that was what we did last week. That grouping involved getting the greatest common factor out of one half the problem, greatest common factor out of the second half, and then factoring from there. So 4 terms is grouping. Today we're dealing with trinomials, and Logan told us that was 3 terms. If there's 3 terms, we're going to do this thing called the X method, and I'm going to show you how to do that today. It is a great way of systematically factoring a trinomial. And if there are 2 terms, we'll learn this later this week. 2 terms, we're going to do what's called a difference of squares. X method is what we're going to focus on today. So this is our focus today is X method. Okay, it's going to involve grouping, but to get started, you're going to use the X method. I say gotta, but you don't. There are other ways to do it, but this is, I think, one of the best ways that I've seen in all my years of math for graphing or for factoring a quadratic. So what we want to do here is a quadratic trinomial. What we're dealing with here is, it looks like this: ax squared plus bx plus c. A, B, and C. A is always in front of x squared, B is always in front of x, and C is always the plain number on the end. Okay, so when I talk about A, B, and C, A is always in front of x squared, B is always in front of x, and C is always on the end. If I'm talking about factoring a trinomial, that's what when I say A, B, and C, that's what I'm talking about. So we're going to factor this with the X method. And to learn the X method, you got to learn how to set up the X. Okay, so I draw just a good sized X there. It doesn't have to be huge, just big enough. I'm writing mine big enough to write into, so you know what goes in each spot. So when you make that X, how many spaces are there? 4 of them. You got a space up top, a space in the bottom, and then spaces on each side. Okay, so what we're going to do is put certain numbers in those spaces. The 2 spaces that we're going to get from the problem are the top and the bottom. Okay, the top comes from multiplying A times C. Whatever is in front of x squared, whatever number is there, we're going to multiply it times the C, the plain number on the end. That answer is going to go up top every time. Okay, the bottom number is going to be whatever number is in front of plain x, B. Okay, no calculation needed for that one. Okay, so we're going to multiply A and C together to get the number that goes in the top. The number that goes in the bottom is B. It's the number that's in front of the plain x. Okay, the 2 in the sides are the ones we'll have to find. All right, the ones we have to find, we're going to call them M and N. We need M and N have to multiply to be the same number as A times C. It doesn't necessarily mean that they'll be the same 2 numbers. Think about this. What if A times C was 12? And maybe A was 4 and C was 3. 4 times 3 is 12. What other 2 numbers could multiply to be 12 that are not 4 and 3?
6 and 2.
6 and 2. M and N could be different numbers. They may be the same two numbers, but it's not likely that they are. Okay, they could be though. Okay, so we need to M and N, the numbers on the sides, have to multiply to be the same thing as A times C, but then they have to add to be whatever B is. Okay, we need the numbers to multiply to be the same thing as the top, add to be the same thing as the bottom. Okay, and that if we can find those, then that's going to allow us to use this X method to rearrange a trinomial into a polynomial that has 4 terms, and that'll allow us to group. Okay, so this is we're going to do several examples today, and I think the best way to learn this is just by putting some numbers in there and actually doing it. Okay, again, what's the most important part about being able to factor? It's knowing your multiplication tables. If you don't know your multiplication tables, you're going to have trouble with this. You've got to know them. If you know them, you're going to be a lot better at this than folks that don't know their multiplication tables. So let's look at a trinomial. 2x squared plus 7x plus 6. Okay? So what's A in this problem? 2. What's B? 7. What's C? 6. Okay, so we know what those are. So now, when we make the X, well, before I start, let's go through the steps. Is it in descending order? Yes. Is there a GCF across the whole problem? No. 2 and 7 and 6, all 3 of them don't have something in common. So I don't have a GCF at all for the whole problem. Now, I'm going to set up my X. To get the number that goes on up top, what do? Multiply A and C. 2 and 6. Multiply together would be 12. So a 12 up top. What goes in the bottom? 7. It's always going to be the B. Whatever's in front of the plain X goes in the bottom. So we need 2 numbers that multiply to be 12 and add to be 7. Well, if it were 6 and 2, 6 times 2 is 12. What's 6 plus 2? 6 plus 2? 8. Okay? That's not quite the right number, right? What other numbers multiply to be 12? 4 and 3. What's 4 plus 3? 7. That's the right 2 numbers. Okay? So our side numbers, M and N, are 4 and 3. It doesn't matter if you put the 4 here or the 3 there. Just either way. Okay? Doesn't matter. Now, the next step is the changing a trinomial into something that has 4 terms. And what we're going to do is we're going to replace this middle piece with these 2. Okay? So it's going to be 2x squared plus 4x plus 3x plus 6. Okay? We're taking this and instead of having a 7, we're splitting that 7 up into a 4 and a 3. Because doesn't this still equal 7 if we added those 2 back together? Yeah. So this blue problem is exactly the same as this. It just looks different. It's longer. And it's got 4 pieces in it, which allows us to then use grouping to factor. Okay? All right? Using grouping to factor is going to be what we're going to do. All right? So, first 2 together. First half of the problem. 2x squared and 4x. What's the GCF of those 2? 2. And they both have an x, so I'm going to pull an x out. What's that leave in the parentheses here? What times 2x gives me 2x squared? 1x plus what times 2x gives me 4x? 2. So a plus 2. Then I want to factor the second half. Positive 3x and 6. What do they have in common? 3. It's a plus 3. What's left in the parentheses? X plus 2. Because 3 times x gives me 3x. 3 times positive 2 gives me positive 6. Notice that the parentheses match. We saw that last week when we were doing grouping, right? So that means it worked and we did it right. The parentheses are matching. So what's our final factors for this problem? X plus 2, and then 2x plus 3. Good job. We factored our first trinomial there. It's not. But the key is getting the x. If you can get this x set up correctly, the factoring part we've already done. We already know how to do that. But it's getting this x set up correctly that's going to be the kicker and the hard thing, because you got to know your multiplication tables and you got to watch signs when they start putting positives and negatives in there. Okay, so we're going to do some examples of that to try to get better at this. All right, so let's do another one. Example B. X squared plus 3x plus 2. All right, so we're taking A, B, and C, and we're going to set up our x for that. What goes on the top of the x? What's in front of x squared? 1 times C. So 1 times 2 is 2. And on the bottom, we've got a 3. We need something that multiplies to be 2 and adds to be 3. 1 and 2. Okay. Now we rearrange this 3-termed trinomial into something that's got 4 terms. So we're going to replace this 3x with a 1x and a 2x. X squared plus 1x plus 2x plus 2. It technically does not matter whether you put the 2x in the front or the 1x in the front. It works either way. Does it make sense why I put the 2x closer to the 2? Because I think in GCF it's the next step, and I know 2 and 2 have something in common. So that's why I'm putting those together. It doesn't matter, though, if you do it the other way. Okay, it'll still work out at the end. All right. So first half, what's the GCF of those two? 1x, yeah. And that leaves what in parentheses? X plus 1. Good job, Aubrey. Second half, positive 2. Using x plus 1 in parentheses there. Final factored form. X plus 1 and an x plus 2. Not hard. Just got to take the time to do it. Learn the process. Now, so far, the first two had only positive numbers in it. Let's throw a negative number into the game and see how that goes. So let's say we had 2x squared minus 7x plus 3. So I'm putting one negative number in here to work with. Okay. So what goes on the top of the x? 2 times 3. A times C. Guys, remember, it's front times back. 6. 2 times 3 is 6. That goes up top. On the bottom goes the B, which is a negative 7. The sign goes with it. All right. So we need something that multiplies to be a positive 6 and adds to be a negative 7. One times 6 is positive 6. 1 plus 6 is positive 7, not negative 7. So we're close. What could I do with the 1 and the 6 and still get a negative, or add to be a negative and still get a positive?
2 negatives equal a positive.
Yeah, if I multiply 2 negatives together, that equals a positive, right? So negative 1 times negative 6 is still positive 6, right? Well, what's negative 1 plus negative 6? Negative 7. So that's the right numbers. Just got to get the signs right. So double negative on that. So that's negative 1 and negative 6 on the sides. going to take that and replace the negative 7x in the middle with a negative 1x and a negative 6x. So 2x squared minus 1x minus 6x plus 3. A common mistake is folks want to change this number at the end when they're doing it, and they want to put that 6 there. That doesn't, the only thing that's changing is the stuff in the middle. Okay?
Which is double negative.
Then it's a double negative because we want it to multiply to be positive and add to be a negative. So we group them. First pair together. Say it again, Ty. Does this one, is this divisible by 2?
No.
No. Well, what do both of them, they both do have what? They both have an x. 2x squared and 1x both have x's. Nothing else that goes with the numbers, but an x is a common factor. So that would be what? What's left in here? 2x minus 1. 2x minus 1. Okay. Now, second half. What kind of 3 should it be? 3 is the right number. Be a negative because this minus sign. Whatever sign you've got right here is going to be what the sign of what you're pulling out. So we're going to pull out a negative 3. And then what's that leave in the parentheses? 2x minus 1. Because negative 3 times 2x is negative 6x. Negative 3 times negative 1 is positive 3. That's why that changes signs there. Parentheses match. We did it right. Factors at the end. 2x minus 1, x minus 3. It's not. The key is getting the x filled out. If you can get the x filled out, the rest of it's easy. Okay? Do this one. 4x squared plus 5 minus 9x. First things first, though. What's the first thing we should always check? Descending order. Is this one in order? No, we got to rearrange it. 4x squared comes first. What should come next? The minus 9x, and then the plus 5. Now it's in descending order. Next thing we check for is the GCF. Do 4, 9, and 5 have anything in common other than 1? No. So we're going to go to our X method. What goes up top? 20. Positive 20 or negative 20? Positive, because it's positive 4 times positive 5. So that's positive 20. What goes in the bottom? Negative 9. Good job. We need two numbers that multiply to be positive 20 and add to be a negative 9. Okay, 10 times what is 20?
2.
Okay, could it be negative 10 and negative 2?
No.
That still gets us positive 20, right?
Yeah.
But does it add to be negative 9?
No.
No, so we know 10 and 2 are out. What other options do we have to multiply to be 20? 5 times what?
4.
5 times 4. To multiply to be a positive and add to be a negative, we know they both have to be negatives, right? So negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9 when you add them. So negative 4 and negative 5 are the right numbers. So negative 4, negative 5. Redo the problem so that it has 4 terms. Does it make sense that I put the 4x in the front with this one? Because they look alike, don't they? It works if you don't do it that way, but it sure is easier if you do. So think about when you're rewriting those, what would be easier. Okay. Now, what do these two have? A 4 and an x. So 4x. What's that leave in the parentheses?
Negative x minus 1.
Minus 1, because what times 4x gives me 4x? 1 does. And then the second half, what do they have in common? A negative 5. Remember, I'm going to use the sign that's in front of this, and then the GCF of those two is 5. So I'm going to use a negative 5, and that'll leave me x minus 1 in parentheses. And the final answer. X minus 1, 4x minus 5. Okay. It's not. But the key is the X method part. The X part, if you can get the X right, the rest of it's easy. But you got to get the X right to make that happen. Okay. Let's look at another one here. Let's see, 2x squared plus 13x. Let's put the negative sign somewhere else this time. I'm going to put it on the end. Let's put a negative 7 right there so that the negative sign's in a different place. So is this one in the right order? Yes. Yes. So we're ready to count the term or look for a GCF across the problem. I see 2 and 13 and 7. I know all three of those are prime numbers, so I don't have any GCF across there. And so I'm ready to do the X method. So, what goes up top? Good job. Negative 14. On the bottom, positive 13. So we need to multiply to be a negative and add to be a positive. What do we know? What does it take to multiply to be negative? Say it again. A negative times a positive. So the signs are going to be different on our sides. Okay, one's going to be positive, one's going to be negative. Which one will be big? Which one's bigger, the negative or the positive? Why is the positive bigger on this one? Because the number it adds to be is positive. The number it adds to be positive. So if I'm going to add a negative and a positive, then the positive should be bigger, right? Because it's going to multiply to be a negative, but it adds to be a positive. So what numbers multiply to be negative 14 and add to be positive 13? Let's think about numbers that multiply to be negative 14. I know 7 times negative 2 is an option. But what's 7 plus negative 2? Negative 2 times or plus positive 7. Be 5, not 13, right? So we know those are out. So those are not the right ones. What other option is there to multiply to be 14? And negative 14, right? What's 1 plus negative 14? 1 plus negative 14. Negative 13. So the sign's wrong. The negative needs to be on the 1 because negative 1 plus 14 is 13. Negative 1 times 14 is still negative 14. All right. Now, doesn't matter what order I put them in inside there, but I've got to just replace the 13x with those. I'm going to replace them in this order. I'm going to put 2x squared plus 14x minus 1x minus 7. It works the same way if you did it the 14 last. But I know 2 and 14 have what in common? X and 2. What's that leave in the parentheses? What times 2x gives me 14? X. 7. Is it minus 7 or plus 7? Why is it plus 7? Because there's not a negative in there, right? So it can't magically create one. Now, what do these two have in common? They're both negative. What number goes into 1 that also goes into 7? 1. So it's a -1. And then what's in the parentheses? X plus 7. Because what times -1 gets me -1x? X. What times -1 gets me -7? A +7. So that's why the plus. So when we pull out a negative, that does change the sign. Okay. Final answer. X plus 7. 2x minus 1. The matching parentheses is 1. The other stuff is the other one is the stuff in front. No, we got a couple more. Give me time. We gotta get all of the different scenarios that can happen. So we got x squared minus 8x minus 6. It is in descending order, so it's ready to do the x with. -6 up top, -8 on the bottom. So we got to try all the things that multiply to be -6. So what's one option?
3.
-6 times 1, but that adds to be what? No. -6 plus 1. -5. Not the right one. Okay. Could be -3 and 2. Does that add to be -8? No. If I did -2 and 3, that gets worse because that adds to be a positive, right? If I did -1 and 6, that's worse. It adds to be a positive. Is there anything that works there? No. I tried every option for multiplying to be a -6, and none of them added to be -8. If that's the case, this is what's called a prime trinomial. And it cannot be factored. Well, not necessarily no solution, but it just means it can't be factored. I'm going to do some stuff after this where that means factoring can't be used to solve it. You'll have to use a different method. Knowing that it's prime means you got to do something different. Okay. Now, so there's one that can't be factored. The key though is don't just assume because you can't find the right factors that it's prime. You've got to make sure you try every possibility for that number up top. Okay. Don't just try one of them and say, oh, it didn't work. It must be prime, and write it down. Understand that prime doesn't come up very much when we're trying to learn how to factor trinomials. I'm not going to give you very many of them that can't be factored. Y'all understand that because that doesn't help you learn how to do it. You've got to do some that. So prime doesn't happen very often. So don't give up too easily on this stuff. Let's do this one. 3x squared plus 24x plus 45. So fairly large numbers there. And that sometimes can make it difficult, but we've got to keep in mind it's in descending order. Good. What's the next thing? Greatest common factor. We got 3, 24, and 45.
3.
Does 3 go into itself?
Yes, once.
Yeah, it does once. Okay, how many times does 3 go into 24?
8.
Does 3 go into 45?
No.
Try. How many times? 40. Yeah, 3 can go into 9, and 9 times 5 is 45. So 3 would go in 45. So 3 is the GCF across the entire problem. So this one we have a GCF at the beginning. So let's pull that out. 3 parentheses x squared. Y'all said 3 went into 24 8 times. And how many times does 3 go into 45? Nope. It goes more than those. More than 3 times 5 is what? 15. What times 3 gives me 45? 15. Be able to do some math here, folks. This is math class. So now, this 3 that we pulled out, he's the GCF, and it's just going to watch what's happening until we get to the end. Okay? So we're going to factor this part in parentheses as a separate problem. And then just make sure we bring the 3 with us when we get done. Okay? So is that in descending order still?
Yes.
Yeah, we're good to go there. So we're ready to do the X method. 15 up top, 8 on the bottom. That 3 that's out in front doesn't multiply to the end anymore because it's already been taken out of the problem. Okay? Multiply to be 15, add to be 8. 3 and 5, that's good. Or 5 and 3, whichever way you want to do it. So x squared plus 3x plus 5x plus 15. What do the first two have in common? They both have an x. Good. What's that leave in their parentheses? X plus 3. What do the last two have in common? Positive 5. Using x plus 3. X plus 3 and x plus 5. And then we've got to bring that 3 that we pulled out at the beginning down. It was the GCF from the beginning, so don't forget about those. They're part of the answer. Okay. So, not too bad. All right, let's look at one last problem. See how we do with it here. 5x cubed minus 65x squared plus 150x. It is in descending order. Very good. Five will go into all of them. Okay. What else do they all have in common, or do they have anything else in common? Everybody's got an X, right? So we could pull out a 5 and an X as a GCF. So 5X, and then what's that going to leave in the parentheses then if we just pull 5X out of everybody? Good job. What times 5 is 65? Good job. Just a plain 30. No X's on that one. Good job. All right. So we factored out the 5X. Got our numbers a lot smaller. Went from 150 down to 30. So that's a lot easier to do. So we know we're going to do the X method on 30 and negative 13. We think about things that multiply to be 30, and then we'll get the signs right. Negative 10, negative 3. Negative 10 times negative 3, that's positive 30. What's negative 10 plus negative 3? Negative 13. This is the right number. So negative 10, negative 3. It doesn't matter what order we put that in. I'm going to put it negative 10, negative 3, just like you said it. Okay? Now, that allows, I got to rewrite the parentheses part as the x squared minus 10x minus 3x plus 30. group. The first half, what do they have in common?
2.
Nah, can't have a 2. This doesn't have a number in front of it. It's just x. What's it leave in the parentheses? X minus 10. Now, what do these two have in common? Negative 3. Remember, this sign right here goes with it. So it's a minus 3. 3 and 30 have 3 in common. So a minus 3. And that would leave us x minus 10 in parentheses, because negative 3 times x is negative 3x. Negative 3 times negative 10 gets me the positive 30 that was there. Okay? So the factors for that part. And then what else do we have to put down there? The 5x that we brought out at the beginning. And we factored out one of the bigger ones that you would have to do. Okay. X method is just the beginning. If you can get the x right, the rest of it's not that bad. But getting the x right is the hard part, okay? And that's the part that takes some number sense that you got to have out of that. So you got to have some number sense about you, which is knowing your multiplication tables and being able to add and subtract in your head.
Okay.
My son had pictures that he wore black and white last night. Max spring spring pictures on the coldest day of the year.
Yeah.
Don't take it.
Oh man, you got a whole black bottle stack. Yeah. Perfect. Thank you, sir. I appreciate it. What's up, dude? As soon as it's built. Unless it's emergency. Is it emergency? Yeah, okay. If you can wait, you can just wait for her. She'll be back soon.